So here we have a polynomial function, and we're going to apply the leading coefficient test, determine the zeros and their multiplicities, and then with that, we're going to do a quick sketch of the graph. It's pretty easy. First thing is leading coefficient test. What you're doing is looking at the leading coefficient, which is 1, and the degree, which is 4, which is even. So when you have a positive leading coefficient like 1, and an even degree, 4, this would act like a positive x squared, which is a parabola that starts up and ends up. So that's how I think of it. So the leading coefficient test says this function will start up and end up. So that's pretty easy. The zeros. Zeros, you just find out where this function equals 0. So we're going to do it with factoring. The obvious factor here is a x squared. And then factors of 20 that add up to -1. That's a simple quadratic left over. So it's x minus 5, x plus 4. And now we're going to identify the zeros and their multiplicities. So according to this, if you solve these factors, you get x equals -4 right here, x equals 5 right here. Now this x squared is like an x times an x. So you get x equals 0, but you actually get that twice. So you have to keep that in mind when you look for the multiplicities. The multiplicity of x equals 0 is 2. Multiplicity of x equals 5 is 1 because that happened once. And same thing for -4. That's going to really help the graph because odd multiplicities, the graph goes through the intercept, and these zeros are x-intercepts. And even multiplicity, we know it bounces. So my zeros, which are my x-intercepts, are at -4, +5, and 0. Now remember, 0 is the multiplicity of 2, so it's going to bounce. The leading coefficient test says it starts up. That's all I really have to worry about because all my bouncing and going through will tell me how it ends. I just want to double check that it is going to end up. So this has a multiplicity of 1, so it goes through. It's going to bounce off this 0, so I'll show it bouncing off. And then it has to go through this x equals 5, so I'll show it going through. So that is a rough sketch of the graph. What I'm looking for here is make sure that it's following the leading coefficient test, it's going through any odd multiplicity, and it's bouncing off any even multiplicity. So that's all there is to it.